welcome to my YouTube channel. Before I start talking about the law of set algebra, I will go through some proofs to show how do we prove of set relations first. So let's look at hints for our proof. If we want to prove a set is a subset of another set, like if we want to prove S is a subset of T. So what's the definition of a subset? Which means every element of S is also an element of T. So if we want to prove that, we can assume an element of S, like X is an element of S. So we can show that X is also an element of T. Then we can say S is a subset of T. Also, if we want to prove two sets are equal, like S is equal to set T, then what we need to show? We need to show S is a subset of T, which means every element of S is also an element of T. Conversely, it is also true T is also a subset of S, which means every element of T is also an element of S. Then two sets are equal. Let's look at a specific example here. If A is a subset of C and B is a subset of C, then the set of A union B is a subset of C. From the questions, what we already know? We already know A is a subset of C. What it means about A is a subset of C? We can say for every X in A and X is also an element of C. From the second condition, B is a subset of C. What it means about B is a subset of C, which means for all elements of B. And this element is also in our set C. So if we want to prove A union B, the set of A union B is a subset of C, then which means element of A union B is also an element of C. So we can assume or suppose element X is in our set of A union B. And we want to show that X is also an element of C. So from here, what we already know, X is an element of A union B. Then we have X is an element of A, or X is the element of B. This is the definition of the union set. So then we have two cases here. The case one is if X is the element of A but not element of B. So when X is the element of A, we already know A is also a subset of C, then X is also an element of C, because A is a subset of C. The second case is X is the element of B. The X is the element of B, which means X is also an element of C, because B is a subset of C. Then for either case, we have X is the element of A union B, and X is the element of C. Then it indicates the set of A union B is a subset of C. Let's look at the second example here. If we have A is a subset of B and A is a subset of C, and A is a subset of the set of B and C. So what we need to do, keep in mind if we want to show a set is a subset of another set, we still need to show every element of A is also an element of B and C. So we can still suppose X is an element of A. And we must show that X is also an element of B and C. X is an element of the set of B and C, which means we must show X is an element of B, and X is also an element of C. And from here, we already know A is a subset of B. Because A is a subset of B, so every element of X is also an element of B. So if X is an element of A, because we suppose X is an element of A, so X is also an element of B, because A is a subset of B. And because A is a subset of C for some reason, X is also an element of C. Now we can say X is in our set B. Also, X is in our set C as well. So we can say X is in our set B and C because they share the same component or they share the same elements. Then set A is a subset of B and C. Let's look at the third example here. If A is a subset of B, then the set of A and B equals set A. Please keep in mind if we want to prove two sets are equal, then both sides, left-hand side and right-hand side, should be taken into account. So which means we have to prove the set of A and B is a subset of A. And we also need to prove conversely is also true, like A is a subset of the set A and B. So let's do proof for the first condition. How do we prove the set of A and B is a subset of A? It's quite straightforward, as I said before. So we still need to suppose X is the element of A and B. And we want to show that X is also an element of A. So from here, we know X is an element of the set of A and B, which means X is an element of A, and X is also an element of B. This is from the definition of the intersection set. So it's quite easy to see X is the element of A. So the set of A and B is a subset of A. Let's look at the second one. A is a subset of A and B. Now we can suppose X is an element of A. Then X is also an element of B. Why? Because A is a subset of B. So X is an element of A and X is an element of B. It implies X is an element of A and B. Then the condition is true. A is a subset of the set of A and B. Now, from 1 and 2, we know the set A and B equals set A. Hey, let's look at question 4 here. We want to prove if the intersection of A and B is A, then A is a subset of B, because we already proved that in question 3, if A is a subset of B, then the intersection of A and B is A. So now in this case, is it true if we take the condition conversely? So now in this case, we can suppose the intersection of A and B is A. And if we want to prove A is a subset of B, so we want to show every element of A is also an element of B. So we can still suppose X is an element of A. Now, obviously, so X is also an element of A, the intersection of A and B. Why? Because set A equals the intersection of A and B. Now, what we can know it implies X is element of A, and X is also an element of B. Then, therefore, it can be concluded as set A is a subset of set B. So if we want to take question 3 and question 4 into account, then we can say the intersection of A and B is A if and only if A is a subset of B. Let's start with law of set algebra. So first law is identity law. We have two conditions here. The first one is A union empty set is A itself. So we already know from the definition of the union set, we know we have two collection of all elements of A and all elements of empty set and into our new set. But because we don't have any elements in our empty set, so when in this case we only consider A as itself. And the second one is the intersection of A and universal set. So from here we know if we have two sets and the intersection of A and B equals A, if and only if A is a subset of B. So we can look at universal set and A. The relations of A and universal set is A is a subset of our universal set. So that's the reason why the intersection of A and the universal set is A itself as well. And the second law is commutative law. I know you guys may know some law of algebra for our real number system. So in this case, this commutative law is really similar as the law of algebra. So it's really similar as A plus B equals B plus C. It satisfies the law of algebra, but it also satisfies our law of sets of algebra. So the first one is A union B equals B union A. And the second one is the intersection of A and B is the intersection of B and A. And also you can also use some Venn diagram to show they are really same. A union B means we have a set A and set B here. And we shadow this region indicated A union B. But B union A is quite similar. It's just we have two sets and we have a set B and set A here, and it really indicated the same area. And for B, for intersection sets, we have, for example, we have set A here and set B here. The intersection of A and B, it really indicated the part of this part. This part really indicated the overlap of A and B, which means the intersection of A and B. And conversely, the intersection of B and A, it also indicated these regions. here. You can write it as intersection of B and A. Next, the law of set identity is associative law. So it's also related to law of algebra in our real number system. So either of two laws relating to number operation of addition and multiplication stated as here. This means the term of factors may be associated in any way desired. So which means you can change any order you want. You can calculate the b plus c first, or you can calculate it a plus b first, or you can calculate a plus c first. Whatever you want, they also indicated the same result. It's really similar in multiplications conditions. You can calculate the b times c first, or you can calculate the a times b first. It doesn't really matter. It doesn't really has any impact on our result. So that's really similar in our set. So we can, if we want to find the union of three sets, then you can calculate the union of a and b first, or you can calculate the union of b and c first. For the intersection of three sets, you can also calculate the A and B, the intersection of A and B first, or you can calculate the intersection of B and C first. It doesn't really matter because the results are same. Thanks for watching my YouTube video. If you have any questions, or if you have any other specific topic you want to listen, or you just want to give me some advice, I'm very welcome. You can leave your comments below. And in my next video, I will continue going through some set identities. In today's video, I introduced three set identities, which is communicative laws, associative laws, and identity laws. So next video, I will continue to talking about two set identities, which is distributive law and De Morgan laws, and give you guys some ideas about how to prove these two set identities.